informal definition, we're going to start out by saying that the limit is going to be the value that a function f of x approaches as x approaches some particular value. Now, the notation for a limit looks like this, and we're going to read it as the limit as x approaches some number a of f of x is equal to some number L. So if you've never seen the notation, it's probably a lot. But if we look at this picture on the graph, the idea is you're going to have some function, and we're going to consider some x value, so some value along the x-axis. In this particular example, we're going to call that x value a. So what's going to happen is we're going to consider getting really close to it. And right now we're going to look at from either side. So you're just getting closer and closer and closer to that number a. So the limit is going to be what the function is doing as that is happening. So we go up to the number a, and you can see that here would be f of a, right? This normally is what we would call f of a. Well, we're going to call f of a equal to L. Okay, so we're just going to give f of a some number L. Well, because it doesn't always have to be f of a, because sometimes this may or may not be defined. So right now, it is f of a, and the limit and f of a are equal, right? We're going to call it L. But even if this were an open circle, we would still say it's getting close to some number L. So we're saying, where is the function going, right? Not what happens when it actually gets there, but if it continues this behavior, where would it actually arrive to? And so that's why we use the term approaches, right? So it is approaching this value L, right? When it gets there, it may or may not be equal to the value L, but that's not what the limit is. The limit is what is it approaching? So where is it headed, right? If it continues down that behavior. And so we consider one and two-sided limits to get the idea going. So we're going to have a left-hand limit, which means you're going to come in on the left side of the value a. And to note the left hand, we put a little minus up here. And then you're going to consider a right-hand limit, which means you're going to come in on the right side of a. So we're going to denote that with a positive value. So over here, this would be approaching a from the right, where this would be approaching a from the left. Now, a left and right-hand limit can both have their own values. So they're not always equal to the same number. So this could exist and have a value. This could exist and have a value. But the note here says that in order for the actual limit to exist, those two values need to be the same.